So what do we need to be concerned with this rational function? Do you guys remember when you have a fraction, what do we need to be concerned about? We did it back in chapter 8. Anyone? How about where the denominator is equal to 0? So if we look at where cosine x equals 0, let me draw a little unit circle. And our 4 main points. If you recall, along the unit circle, it goes cosine, comma, sine for every x, comma, y. So on this graph, where is cosine x equal to 0? 3? At where? 90 degrees, and where else? And 270. Now what I'd like us to do is let's transition to radians. So let's say pi over 2 and 3 pi over 2. So there's a problem when x equals pi over 2 and 3 pi over 2. Does anybody remember from chapter 8 covering rational functions, what happens when the denominator was equal to 0? What happened on the graph? Anybody remember? Emily, you remember? Scott, do you remember? Jonathan? It's undefined, but on the graph, what did we see? A vertical asymptote, okay? A vertical asymptote. So what's interesting about the tangent graph is wherever the denominator is equal to 0, it's going to produce a vertical asymptote. Because tangent x equals sine x over cosine x, it really is a rational function. So what we're going to do, and the other thing I need to tell you is that the period length of tangent is pi. Remember what we learned yesterday, the sine function and cosine function have parent functions with a period of 2 pi. So tangent is just pi, but we're going to use the same process we did. We're going to count 4 tick marks to the right and call it the period length. 4 to the left and call it the period length. But what's interesting then, so it's the same process as sine and cosine. You find the period, make 4 tick marks to the right, call it the period length. But what I want you to notice is with tangent, I have a vertical asymptote at pi over 2. So I'm going to put my vertical asymptote here. And then let's come over here to the graph. 3 pi over 2 is the same thing as 270 degrees. Isn't that the same thing as negative pi over 2? Isn't that the same location? If you go around 270 degrees, or 3 pi over 2, if I rotate negative 90 degrees or negative pi over 2, that's the same thing. So I actually have a second vertical asymptote at negative pi over 2. Okay? Then I need to piece together some other things. What is the tangent of 0? Well, the tangent of 0 is sine 0 over cosine 0. Because I know tangent x is sine x over cosine x. If I want the tangent of 0, it's sine 0 over cosine 0. So I come over here to my unit circle, and the sine of 0 is 0, the cosine of 0 is 1, so this is just 0. So I plot that. Then, what is this first tick mark? What should it be labeled? If the second tick mark is pi over 2, what's the first tick mark labeled?
Pi divided by 4.
Pi divided by 4. And if you're having trouble with that, it's halfway, so half of pi over 2 is pi over 4. Now, pi over 4 is how many degrees? 45. So I want to know what's the tangent of 45 degrees. Well, I go to a 45, 45 right triangle. SOHCAHTOA, tangent is opposite over adjacent. What's the tangent of 45? 1. So watch what I can do then. Pi over 4, the tangent of pi over 4 is 1. Now if I go negative pi over 4, that's a rotation into the 4th quadrant. It's still, you're looking for tangent 45, which is 1, but it's negative 1, like this. Okay? And what I want you to notice is that negative pi over 2 to pi over 2, that is a distance of pi units. The period length is only pi. It doesn't take as long to repeat the pattern. If you remember yesterday, we talked about periodic functions. And a periodic function is like if you took a stamper, and I could make a stamper of this graph, and I could just keep stamping, stamping, stamping it. The period length is how long does it take on the x-axis before it's going to repeat, okay? All right, so let's look in general. If I have y equals a tangent bx, the period is now pi divided by b. If you follow this technique, we don't need to memorize fancy formulas for our vertical asymptotes. What you're going to do is if you always count out 4 tick marks to the right, the second tick mark, left or right, will be the vertical asymptote. And instead of us memorizing some formula for it, as long as you've made your 4th tick mark is the period length, you figure out what that second one is and you have it, okay? The domain. Well, we have a problem with the domain. The domain is going to be all x values except where the denominator equals 0. And in this case, it would be all real numbers except pi over 2, 3 pi over 2. And you do know that it goes infinitely to the right and infinitely to the left. The range is all real numbers. I will tell you just for a preview of next year in pre-calculus, we will write the domain like this. It'll be the set of all x such that x cannot be equal to pi over 2 plus pi n, where n is an element of the set of integers. So it's some pretty fancy notation. We'll do that in pre-calculus. I'm not going to take you there this year in Algebra 2. So I want you to notice what you do is you take your first vertical asymptote and then you just add the period length in this case. Okay? Pretty interesting. All right, so let's do an example here. In example 6, if I want to graph y equals 2 tangent 3x. Oops, let me go back one page a moment here. Something I also wanted you to write down is there is no amplitude. There is no amplitude for the tangent function. Does anybody have their notes from yesterday? What did I have you write down as the definition of amplitude for cosine and sine? Anybody have it? Okay, it was the absolute value of A, but in words, what did it mean? Kaylee?
1/2 minus, or maximum minus minimum.
Awesome. Okay, that was exactly what I was going for. Is the amplitude is 1/2 the difference of the maximum minus the minimum. So why would I say that the tangent graph has no amplitude, Alex?
Because it's all real numbers, like the maximum and minimum, so it doesn't
Exactly. Okay, exactly. If you look up here, there is no maximum. My graph is increasing without bound. It's going to infinity. And as I go to the left, it's decreasing without bound. You can't attain a maximum or a minimum. So there's no amplitude there. But in that general case where we have y equals a tangent bx, you do want to identify the a value because that's going to help us, but don't write down that it's an amplitude because that's not true. Okay? Then the period length here is tangent has a period of pi, so it's pi divided by, in this case, 3. So let's write down some steps like we did yesterday, okay? So step 1. You want to determine A and the period. Step 2, when you're graphing the tangent function, make 4 tick marks left and right. Label the 4th tick mark the period length. Okay, so again, step 1, determine A and the period. Step 2, make 4 tick marks left and right. Label the 4th tick mark the period length. Number 3, make vertical asymptotes at the 2nd tick mark, left and right. Okay, step 3, make vertical asymptotes at the 2nd tick marks, left and right. Then what you're going to do is you're going to plot a point at 0, 0. Then you're going to do the 1st tick mark, comma A. And then you're going to go left a tick mark down to negative. Then you'll go down to A. Okay, so you always do a point at 0, 0. Then you do a 1st tick mark right, comma, A. And then do left a tick mark down to negative A. So like I mentioned yesterday, you want to keep reading through your 4 steps because if you go through them, 10 times, hopefully we'll get the steps stuck in our heads. So here we go. We already determined A in the period. So let's make 4 tick marks to the right, and I'm going to label it pi over 3. I'll go left 4 tick marks and label it negative pi over 3. We'll go ahead and go up 2 units for A, down 2 units for A. Now, what would be the label for the 2nd tick mark? What's half of pi over 3? Pi over 6. Good. So we'll label that. Then what happens at that 2nd tick mark? It becomes a vertical asymptote. Nice. So let's plot that. Then you're going to put a point at 0, 0, and then you go to the right 1 tick mark up to A. Left 1 tick mark down to A. Then what we could do is we could go and add 4 more tick marks. 1, 2, 3, 4. That's another pi over 3. So let's call it 2 pi over 3. And then 2 from there, from my last tick mark, would be another vertical asymptote. And then I could do a 2nd period length of this. And what I want you to notice is the distance between vertical asymptotes is pi over 3. Pi over 6 plus pi over 6 is 2 pi over 6, which is pi over 3. The other thing that's interesting is that if you notice I have an x-intercept at 0, the next intercept is the period length apart at pi over 3. Okay? So let's identify a few things here. My vertical asymptote is at plus or minus pi over 6. Then my domain is going to be all x's except those two. And my range is all real numbers.